truck and wagons information that we can be able now to determine the load time, where to find out other fixed time, sport, maneuver, dump time, and we can be able to determine the number of units for truck or wagon required, and then we also be able to find out the productions given the actual number of units that you allocated. And let's apply that in problem 3, the last problem for today. Given the following information on a servo and truck operation. So basically the servo, it will be used as the excavator to load the material on the truck. And the servo productions at 100% efficiency. So they give that 371 BCY per hour. Job efficiency, 75%. Truck capacity, 20 BCY. The truck cycle time, excluding load. So they already give us the 0.5 hours. So truck cycle time. Calculate the number of trucks theoretically required. So basically that is find out the N capital in that equation here. And the production of this combination. Calculate the expected production if 2 trucks are removed from the fleet. So 2 scenarios that we need to determine. So let's work on this one. The first one we need to determine is what is the load time. What is the load time? It's important to determine the load time so that we can be able to determine the truck cycle time. Then the load time, based on the equation, it equal to whole unit capacity divided by the loader production at 100% efficiency. So whole unit, that is a truck, 20 BCY, divided by the loader production, in this case servo, at 100% efficiency, 371 BCY per hour. So from that one here, we can get that equal to 0.054 hours. Just for load, waiting the servo put the material on the trucks. And they give us the truck cycle time excluding loading, 30 minutes, 0.5 hours. So you can add them. This is load time, they exclude, and then plus 0.5, you get the truck cycle time. Truck cycle time equal to cycle time excluding loading plus loading time, 0.0054. From here we have it 554 hours. So when we have the cycle time, we can do anything with the question here. Go to the A, scenario A. Calculate the number of trucks theoretically required. So we have the number of truck required, and that basically the N capital, and the equation is whole unit per cycle divided by load time. Whole unit per cycle. Okay, so that is the 0.554 divided by the load time. Load time is divided by load time, as you can see there, 0.54. So we have that is 0.3, and that is equal to, we don't want to put the unit in a fraction. We need to round up or round out, right? So let's round out to make it more some buffer for the truck. So select 11 unit. So from that, the question also asks, so that is a theoretical. And what is the production of this combination? What is the production of this combination? So from that one, we have productions. And if we choose 11 units, it means that we have excess capacity for the truck. So whatever the bottleneck is from the excavator. So the production in this case, the bottleneck is the excavator. So we can have the excavator production. And that it will be 371 BCY per hour, and we determine. But here the efficiency only 75%. So you have time %, so it's 0.75. So you get that is 278 BCY per hour. So that is the productions when we put the trucks with some excess capacity, because we only need 10.3 trucks, but we put 11. What if we only put 9 or 8 or 10? Then it goes to B, calculate the expected productions if 2 trucks are removed from the fleet. So from that one, what if we put less, which means that the truck's capacity less than the salvo capacity? Then that comes to the equation of the expected production. And that equal to the actual number of units divided by N times the excavator production. So actual number of units, and you can see we select go down 2 truck remove. So what does that mean? We will have the 11 minus 2, that's the actual unit, divided by N, 11, times the excavator productions. So it will be in here also efficiency, so 278. So you will get that number equal to 243 BCY per hour. Bottom line, if we remove the trucks, of course the production will be less. And that the answer, and that conclude our lesson 4.